Again, so we're starting the recording just a little bit in the middle, and we're just talking about the different things we can measure, such as weight, distance or length, area, volume, rates of change, and in the system that we're probably most familiar with here, we measure our weight in pounds. Okay. Pounds and ounces, I should say. Distance and length is measured in inches, feet, yards, and miles. Area is all square inches, square feet. I've never heard square yards. We have square miles, and an odd thing, acres. Okay, but these all measure area. And nobody knows the conversion between acres and square miles off the top of their head, right? I mean, you can look this stuff up, but we're just not really accustomed to it, okay? Volume, we have cups, quarts, and gallons. Also barrels, but that's for larger things. And you also have cubic inches and cubic feet, which are really only deal with when you're paying the water company, because they charge you in hundreds of cubic feet. Okay, and then rates of change. These are all of our different things. Probably the most, I'm sorry? The most familiar one will be like miles per hour. That's for speed, distance over time. But there's many others. Just yeah, feet per second. That's for speed. But then you can also have distance, weight over, that's time, or volume over time. It doesn't, not as often, okay? And okay. So then, for the metric system, we measure in grams. Okay. And distance is measured in meters. And area is measured in square meters. Volume is either cubic meters or liters. Okay. And rates of change, you will have things like similar corresponding things here, okay? But the metric system, we only have pretty much just one per thing, with the exception of volume, which can be cubic meters or liters, but they all have prefixes, okay? Okay. Now I do have to make one distinction, and that is technically when we're using grams, we are technically measuring something called mass, okay? So, and technically not weight, but the difference is that weight depends on the mass and gravity, okay? So if you go to the moon, they say you weigh less, and that is correct. But if you go to the moon, your mass does not change, okay? You are still the same amount of person as you are on Earth, okay? So even though your weight has changed, your mass has not changed. But because I don't think any of us will be going to the moon, we don't have to worry about our weight really changing, and so because the gravity is always going to be the gravity on Earth, the weight is not we don't have to worry about the weight changing in different places of the world. So weight and essentially mass are equivalent as long as we stay on Earth. Okay, is that distinction okay? So anyway, we're going to deal with the metric system here. And let me just save this slide. I guess I could post these slides also somewhere. And let's see, April 28, slide 01. Okay, so let's just, for example, start off with something like the gram. Okay, we have prefixes that are larger, or actually I'll start off with the smaller prefixes. Okay, and we have things like deci, centi, and milli. Wait, does milli have only one? No, it has two. Just weirding myself out here. Okay. Okay. So milli means smaller by a factor of 1,000. Centi means smaller by a factor of 100, and deci means smaller by a factor of 10. And then you have prefixes for larger. Deca, hecta, and kilo. I think kilo only has one L. It seems funny here, okay? And these are all larger, and they are larger by a factor of 10, 100, and 1,000, okay? So these prefixes you must learn, okay? You must learn and memorize. Okay, so that means there are, so just a few examples we can ask. How many milligrams in a gram? This is just a very simple question. Don't shout out your answer. How many milligrams in a gram? Just think about it. Okay, and now say your answer is 1,000 milligrams in a gram. Okay, what about the reverse question? How many grams in a milligram? Okay, don't shout out your answer. Just think about it. You can write it down. But how many grams in a milligram? Okay, and you would say 0.0, how many zeros? 0.001, okay? So how, if you thought it was 3 zeros and a 1, or 1 zero and a 1, or, something other than 2 zeros and a 1, maybe it would do us good to talk about going through converting from one to another here, okay? so let me actually cut this. Okay, so if you're going down the tree, or down this list, okay, so if you start here, to go from here to here, you multiply by 10. So each step down, you are multiplying by 10. Oh, I skipped a step, sorry. There's technically a 1 here. I'm missing that. I'm gonna get in trouble here for teaching you bad stuff. There's a 1. Okay. What's going on here? Okay. And do we all know our powers of 10? Yes.
I think from gram to milligram to the proportion to divide by 10.
What's that say?
I think if you go gram to milligram, it should be divided by 10 instead of multiply by 100.
Yeah, but I'm going down. I'm saying milligrams into centigrams, okay? There are 10 milligrams in a centigram, 10 centigrams in a decigram, and 10 decigrams in a gram. So if we're going the other way, yes, we would divide by 10, okay? So let me just do that in another color. And if we go the other way, I'm going to say multiply by 0.1, okay? So in all of these things, I know this picture now looks more confusing than it should be. Okay. All right, and maybe it is also useful to just list off our factors of 10. Okay, do you guys have this down in your notes? Okay, so let's just, and I know this might be review for some of you, but we'll just talk about our powers of 10. And this is probably all stuff you know already. However, I want everything in here to become second nature. So if I say, what is 100 times 100, instantly you should tell me the answer is 10,000, exactly. And if I say, what's 10,000 times 100, you would tell me 1 million, okay? So these are the types of, when you multiply by powers of 10, I want you guys to practice this, okay? And so, depending on how good you are, it might be useful to create some flashcards or something like that, where you can say, what's 10 times 1,000? 10,000. What's 100 times 100? 100 times 1,000 would be 100,000, and things like this. Okay. So we'll anyway, we have we'll start off with the ones. Okay, and then as we multiply by 10, gives us tens, and we multiply that by 10, we go into hundreds times 10, it'll be thousands. So at least this part is nice that we all speak English, because in Germany or in other countries, the And I'm sorry, in other countries, the way they go through these things is different. So we're used to something called, 1,000 millions is a billion, and 1,000 billions is a trillion. And we don't have to get into that. But in other countries, or in Germany, I think it goes from million, and 1,000 millions is a milliard, and 1,000 milliards is a billion. And so things start looking very different. So when they talk about billions of euros, they might actually be talking about trillions of euros, and so it can be confusing. Okay, and going in the opposite direction, we have tenths. Basically, you take all of these things, you flip them around, and change it to the th ending. Okay, so you have tenths, hundredths, thousandths, 10,000ths, and so on. Okay. Okay, so you take one step, that's multiplying by 10. You take 2 steps down, that's multiplying by 100. You take 3 steps down, that's multiplying by 1,000, and so on. Okay? So let's we'll try a few practice drills, and we'll put in the we'll do it with the metric system as well. Okay, so first we'll just try a few practice drills. Okay, so I'm going to just say, what is, so when you have numbers like 100 times 100, it's easy because you just count how many zeros there are, and you just make sure that you have that many zeros appear after, right? You do the first number, the 1 times the 1, and you get 1, and then you count how many zeros you have, and you put in 4 zeros, and we recognize this as 10,000, okay? But I think there's also something very useful in writing what is, 100 times 100, and recognizing that this is 10,000. Okay, so sometimes we're probably used to thinking with the numeric symbols because the rules for dealing with the numeric symbols is fairly easy. You kind of count the zeros, make sure that you got 1, 2 zeros over here, 2 zeros over here, so you make sure you have 4 zeros here. Okay, but we have to be comfortable with saying, okay, 1 with 4 zeros behind it, that's 10,000. 1 with 5 zeros behind it, 100,000. 1 with 6 zeros behind it, 1,000,000. Okay, and again, just like the neuroplasticity video, some of this just requires practice and exposure, okay? And so you can kind of drill yourself. You might seem a little bit odd, but I think this is a worthy thing. All right, so 100 times 100, yes?
So would that 10,000 also be called 10 to the power of 4?
Yes, this is also called 10 to the power of 4, and that comes in a later lesson, okay, when we deal with the scientific notation. But that's going to be very important because we're going to have to deal with scientific notation as well. Okay, and so we're going to revisit a lot of these ideas and topics more in the future, to the point where you're going to be sick of it, but I want it to be kind of just second nature and instantaneous, okay? You can't be, on the job hesitating how many you know, how many thousands go into a million, or how many milligrams in a kilogram, or how many deciliters go into it. You know, these are things that we can't hesitate about. We have to know these right away. Okay, so maybe just a few drills. So I'm gonna just put a few questions up here, and I'm going to write out the words, and I'm gonna have you multiply them, and I want you to come up with the answers. Okay, so these are just we'll do some drills here. Okay, so we'll start off with, and don't shout out your answer. No. I should write 1/10. Now, if you have to convert these into numbers and then multiply and convert them back, that is okay in the beginning. But I also want us to just start trying to do these things in our head. So try to visualize the number in your brain and see if you can answer these. So some of you guys have worked through it already, others of you are thinking hard, and that's great. It is good to challenge your brain and struggle, and if this is already easy for you, then you got nothing to worry about, or at least for this part. Okay, are we ready for some answers? You guys need another minute. Yes. I'll put the answers down, okay? All right, so here we go. 10,000 times 100. 1 million. 1/10 times 100. 10. 1,000th times 100. 1/10. 1,000 times 100th. 10. 1,000 times 1,000. 1 million. 10 times 10,000. 100,000. How do we do? Okay, so if you did great, that's great, and if you didn't, let's I guess I want you to start working through, counting forward and counting backwards, okay? And so you learned how to count, right? You learned 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay? And you can you know, in the beginning, when you were learning addition and subtraction, you would count on your fingers. And you would say things like, what's 3 plus 4? And you'd start off with 3, and you'd go 1, 2, 3, 4. And you'd say, oh, that's 7. Okay? So in the same way, I want you to start counting, okay? And just go, you know, 1, 10, 100,000, 10,000, 100,000, million, okay? And in the opposite direction, you know, 10th, 100th, 1000th, 10,000s. And think of this as kind of addition going up, subtraction going down. So when you see something like 10,000 times 100, okay, in your head you should be going, okay, 100, if we're, this is now, you're thinking the number 2, right? Because, let me just, you can, so you can think of this as 0, 1. So this is essentially scientific notation. And this is, okay. So these are essentially in scientific notation. If you're already familiar, if you're not, it's okay. This is basically how many zeros do you have here, okay? And so in your head, when you see 10,000, I want this to instantly think 4 zeros, okay? And you think 100, I want you to instantly think 2 zeros, okay? And then you say, okay, well, what's 4 plus 2? That's 6, so I'm going to have 6 zeros, and you need to instantly associate 6 with a million, okay? So if you're struggling with this, I want you to, I'll show you how to make some flashcards in the beginning, and then you can start giving yourself some drills this way, okay? So you think 1/10, I want you to think -1. And you think 100, you think 2. So you have -1 plus 2 gives me +1. That's how I end up at 10. Does this make sense? Are we feeling kind of okay? So 1,000, what is that in terms of how many zeros or places? -3, 1,000. So we got -3. 100 is 2, so -3 plus 2 is -1. So I end up with 1/10. 1,000 times 100. 1,000 is a +3. 100 is -2. 3 minus 2 gives me 1, which we think of as 10. 1,000 is 3. 1,000 is 3. 3 and 3 is 6. 6 zeros, a million. 10 is 1. 10,000 is 4. 1 and 4 make 5. 5 converts to 100,000. Okay? So, if you need to make flashcards, on one set of flashcards, I want you to have on the front, okay, you're going to have something like 10, and then on the back, you're going to say 10, like this, okay? And you'll say something like 1,000th. And on the back, you're going to say, or maybe not 1. You'll put -3, okay? -3, and you'll have 0.001. Okay, so -3 zeros essentially, okay? And 1 million.
So 1 million would be -6.
1 millionth would be -6, exactly, okay? Exactly. So on the back side you will have 6, and you'll say 6 zeros, okay? And you can do this with all of the numbers, if you want to do 1 millionth. -6. So -6 zeros technically means 5 zeros and the 1 goes in the 6th place, okay? So the 1,000th, it's not 3 zeros, it's 2 zeros, and the 1 goes in the 3rd place, okay, when we're dealing with the negative side. Okay? So that's going to be one set of flashcards, and then the other will just be kind of like, you're going to have to deal with like the times table, but not really, and you just come up with different things, and you just say things like 100 times 100. And on the flip side, you're going to say 10,000, and you'll put the numeric answer on the backside with the answer. Okay. And the reason why I emphasize this is because sometimes when you're talking, you don't talk 1000 or 0.0, and sometimes you can talk that way. But generally, you're talking with numbers. You'll talk about tens and hundreds and thousands. And so it's important that we can basically visualize and think about these numbers as we are speaking, okay? Because when we're dealing with numerals on a page, our brain kind of recognizes and sees these things as numbers. But we also have to be able to do it through our ears and when we speak. So these conversions are okay. Is this okay? Good? Good? All right? Okay. So again, this is the key here. I guess I can post this on a website somewhere. So I will have Carrie email you guys with where I'm going to post this video and stuff. Okay. Okay, so let's bring this back to the metric system. Okay. So we have milli, centi, deci, no prefix, deca, hecta, kilo. Okay? And here you can put in the measure, whether that's gram or meter or liter, whatever it might be. This is the unit of measure. Okay? This essentially, I'm going to put in the decimals, 0.001, 0.01, 0.1, 1, 10, 100, 1,000. And then I'm going to put in the exponent. This is the -3, -2, -1, 0, 1, 2, 3. And the word is thousandth, hundredth, tenth, 10, 100. I guess technically this is 1, 100, and 1,000. So you might want to, if you need to put these on flashcards, also you can, but this needs to be also instant now. So, for better or worse, we don't encounter deca and hecta that often. We generally just talk about 100 grams versus a kilogram or something like that. We don't really say I have 1 hectogram. That for just there's nothing wrong with saying I have 1 hectogram, but generally people will say I have 100 grams of something. Okay, or if you have 1,000, you'll just say I have a kilogram or 1 kilogram or something like that. It's not wrong to use deca or hecta, but they're just not commonly used. So we'll just try a few drills here. Okay, so let's see. All right, so I'll say how many centimeters in a kilometer. How many okay, or 10,000. Here, maybe I'll put this on a new slide, okay? Is that okay? So I'll copy this, and we'll slide this up so you guys don't have to crane your necks. And let me just copy this thing. Okay, so work through your so these involve, a few steps, right? You gotta think of the difference between sets. Okay, so all right, so how many centimeters in a kilometer? The answer is 100,000. Okay, so I think this gave you some trouble here. All right, let's talk about how did I do this, or how do we arrive at this answer? Okay, so centimeters. What is the exponent associated with centimeters? -2, right? What's the exponent associated with kilometers? 3. Okay, so what's the difference between -2 and 3? Oh, it's 5. Okay, so you have to think of the number line, right? So what do you need to add from -2 to get to 3? You need to add 5, right? So you must do -2 plus 5 will take us to 3. Okay, so is that all right? Yes. Okay, so then I don't have the other table, but you need to think, okay, so what is the plus 5 exponent associated with? 100,000. So are you starting to see how these exponents are vital in our experience with the metric system, okay? And once you get a hang of the metric system, it'll be easy, okay? Because all things in the metric system, whether it's grams, meters, liters, they all use the same system, okay? You don't have to worry about 12 inches in a foot, 5,280 feet in a mile, or 1,760 yards in a mile, or you don't have to worry about these arbitrary numbers that we have to deal with in the customary system, okay? Which we're used to because we've been exposed to them every single day of our life. But you could understand somebody coming from Europe having to deal with things in the U.S. are always confused in the beginning. Okay. But I guess it's just different systems and they work. Okay. All right. So how many milligrams in a kilogram? What's that? 1 million, right? So milligrams, milli goes with -3, and kilo is 3, so we go +6, and so 6 goes with a million. Okay. Now, if I had reversed this question, so I'm going to just say, what fraction of a kilogram is a milligram? Okay. Then you would say kilogram is 3, milligram is -3, and you would say, okay, well, we're going to do -6. So what is associated with -6? The answer would be 1 millionth. So what fraction of a kilogram is a milligram? 1 millionth of a kilogram is a milligram.
And that 5 zeros and a 1.
Yeah, 5 zeros and a 1. Exactly. Good. Okay, and so this one is a little bit different, but I'm asking 1/10,000th of a kilogram is how many milligrams? Okay, so let me just okay, so 1/10,000th is associated with -4, and a kilogram is 3, okay? So we're going to take 1/10,000th of a kilogram. So it's not asking how many, so I'm not trying to figure out what I need to do to get from here to here. I'm just saying, if I start off with here and I'm taking 1/10,000th, basically I'm going to just add these two numbers together. So if I add these two together, it takes me to -1, okay? So 1/10,000th of a kilogram is technically 1/10 of a gram, okay? But that's not our answer, okay? So this takes me to -1. So this is so our 1/10,000th of a kilogram is 1/10 of a gram. And now the question is, 1/10 of a gram is how many milligrams? Okay, and so yes, the answer is 100, but a milligram is -3. So now we're basically asking how many milligrams is 1/10 of a gram? Okay, so there's a sub-step here. You have to figure out 1/10,000th of a kilogram is how much to begin with, and then we're going to ask how much is that in milligrams. Is that the breaking apart of the steps? So let me just slide that down. And okay, so 1/10 of a gram. So now we have, so now there's essentially another question. So let's see. So let me just break this out. There are two parts to this question. One 10,000th of a kilogram is how much? And the answer to that is 1/10 of a gram. And the second part of the question is, okay, 1/10 of a gram is how many milligrams? Okay, and so 1/10 of a gram is associated with -1, and milligrams is associated with -3. So how do we get from -3 to -1? We have to add a +2, so that's 100. Okay, so we do +2.
Why are we going from milligrams to 1/10 instead of going from 1/10 to the milligrams?
Because we are asking. I guess I could have written this same question in two ways. I could have said, how many milligrams is 1/10 of a gram? And it would have been in the same order as this. Maybe to fit with the original question I wrote, 1/10 of a gram is how many milligrams, okay? But essentially, we're asking how many of a smaller thing fit into the bigger thing, okay? Or how many of this thing fits into the other thing. So we're asking how many of this fits over here. Now, so I'm asking, what do I have to add from here to get to here? Is that okay?
Okay.
It's okay? Maybe.
It makes sense.
Huh?
It doesn't make sense to me.
It doesn't make sense to you?
I would want to add a -2 to get to the -3.
Okay, and that would be the answer to the question of 1 milligram is how much of a 10th of a gram? It's 1/100th. Okay, but that's a little different of, essentially I'm asking how many milligrams are in 1/10 of a gram. I'll write that also, because it's the exact same question.
But is the answer 100 or is the answer 100?
100. The answer is 100. Okay, so let's.
How many thousands are in a 10?
Yeah. So how many milligrams are in 1/10 of a gram? Okay. These two questions, they are the same question. Can we see this, or is anybody confused by the language here? Okay. So, because in English we can rearrange sentences or questions, and they are asking the same thing, but they also feel a little different. Okay, and I think that's why it's causing you some discomfort, because this question at initial glance feels a little different from this question, but they are the same question. Yes. Okay. Well, we'll encounter this much more in the future, and I'm hoping we'll feel comfortable as we get more and more exposure to it. Okay. I don't know if someone's gonna drill you with these types of things, but these are the types of metric conversions I want you guys to feel comfortable with. Okay. How are we doing? Good? Okay. Let's see here. Let me just flip through, just make sure I'm covering all of this. Okay, so we might want to then apply our knowledge of the metric system into regular word problems, okay? So I'll start off with maybe just a simple question, and then we'll complicate it with using the metric system. Is that okay? So a simple question might be, whatever you, okay. Soda cans cost 75 cents at the vending machine.
Kind of expensive, isn't it?
Is that a lot?
Well, in my pocket.
It depends. I guess
Government,
you know, these are cans, not. This would actually be a good price if it was the
Right.
20-ounce bottle. And well, vending machines are just a terrible deal to begin with.
It's none of my business, but you really should go to Costco.
Yeah. Yeah. But in California, you got to pay CRV. Okay. Anyway. Okay. Soda cans cost 75 cents at the vending machine. You have $4. How many sodas can you buy? Is that easy? Okay, so what is our answer? 4, 5, 6, 7. Okay, so what's our answer? How many sodas can we buy? I guess I should ask how much change will we have left?
25 cents.
Yeah. Okay. All right. Okay. So essentially, we just you're just gonna do $4 divided by 0.75, essentially per can. Now we're kind of ignoring this, but so we're just essentially doing 4 divided by 0.75, and we get something like 5 point. No. What is? What am I doing? So 5 goes in there at 375. So we're gonna get 5.333, right? 5 and a third. Okay. Okay, so we can buy 5 cans, and 5 cans cost 5 times 0.75, 375, and then that means we have 25 cents left. Okay. You can write 25 cents this way. This is wrong. To say 0.25 cents. Okay. Because this is 1/4 of a penny. If you were to write 0.25 cents. Okay, so this is not correct. Okay, and we're used to dealing with money, and we can do things like this. Okay, now I'm going to just basically ask a very similar question, but don't get scared. So let me just. Okay. And okay, a certain solution, or we'll say a certain chemical, comes in 750 milliliter bottles. Okay? You have a 4-liter flask. How many bottles are needed to fill the flask?
Is it essentially the same question?
It is essentially the same question, but I just wanted to dress it up a little differently.
Baxter clothing.
So,
Don't forget to recycle. Drop pretty, thank you. Baxter, thank you. Mother Nature, thank you.
Thank you.
yeah, we're measuring volume, and that, yes, and not money, but we're essentially asking, it's the same math operation that we're doing here. Okay, so 750 milliliters, what is that in liters? Yeah, 0.75 liters, right? So 750 milliliters, okay, as we learned, a milliliter is 1,000th of a liter, okay? So I'm going to have 750 times 1,000th of a liter, so I get 0.750 liters. Is this conversion uncomfortable for anybody? I'm sorry?
Can you show us another way?
Show you another way. Okay, so milli, what's the exponent associated with milli? -3, okay? So another way you could do it is you could imagine there being the decimal by the 0, okay? Imagine a decimal point by the 0 here. And -3 means you're going to go 1, 2, 3 decimals over to the left. Okay.
Oh, I see.
So I'm right here by the 750, okay? So if we want to go from milliliters to liters, okay, we think milli is -3. So a milliliter is how many? 750 milliliters is how many liters? I'm going to start with my decimal here, and milli is -3. So negative means I move the decimal this way, okay? And so now I have 0.750 liters. Does that feel okay?
Yeah.
Yeah? Okay.
And you can take the 0 off, right?
And you can drop the 0, exactly. Okay? So 0.750 is exactly the same as 0.75 liters. We will talk in the future about significant digits, and it might make a difference whether to keep that 0 or not. But for now, we can treat them the same. Okay? Okay, so 750 milliliter bottles, and okay, so this is equivalent to 0.75 liters. Is that okay? I hope. Okay, so essentially I'm asking what is 4 liters divided by 0.75 liters per bottle. Okay. Now I want you to notice that the units will cancel, and what I will be left with will be bottles. Okay. Over here, you guys didn't even think about it, but the dollars were units, and they actually canceled each other over here. Okay. But essentially, we're asking the same thing. 4 liters divided by 0.75 liters per bottle. And so this gives me 5.333 bottles. Okay. So it will take 5 bottles and a third of another bottle to fill this flask.
I didn't read the question.
You didn't read the question correctly?
Yeah.
What?
I didn't read the second part. How many bottles are needed to fill a flask? I just like liters.
Okay.
But then I read it.
Okay. Why don't we take a break? How long do you guys get?
Like
10? 10 or 15?
Up to you.
Do you guys? Well, I'll be generous today. We'll say take a 15-minute break, and then and we'll continue on with more of these types of calculations and stuff.